So welcome back, guys. So in the last session, we had started with the biostatistics. There we have discussed about the very basic foundation, that is data. We had to talk about what is qualitative data, what is quantitative data, and then we had to talk about few words about the scales of data, right? So guys, just a revision for you that we have already talked about variable types. In the variable types, right, I mean data only, this is the data only, right, so no confusion. Okay, it can be categorized into two parts over here. I told you qualitative and quantitative, right? Numerical is nothing but the quantitative type. Numerical is nothing but the quantitative data, right? And categorical is nothing but the qualitative data. I told you qualitative can be countable, quantitative can be measurable. We had to talk about the examples as well. Then I told you about the data scale, right? Data scale, if you talk about, guys, here we are having sub-categorization in the qualitative category and the quantitative category. Qualitative is also called as a categorical, quantitative is also called as a numerical. So we can say that categorical is actually divided into two further types. Categorical, in the qualitative category, we are talking about the nominal and the ordinal data scales. So please do remember nominal and ordinal data scale. I told you in which category, I am telling you in which category, that is the categorical, that is the qualitative stage. Quantitative is the numerical, where we are talking about the interval and the ratio. Now guys, if you guys remember, right, if you have listened to me very attentively over there, I told you that in the quantitative data, we are calculating the mean value. Remember, we are calculating the mean value, right? Here, quantitative, it means we are telling the mean value. We can calculate the mean value. Here we can say that interval and ratio, which are the part of numerical only, here we are saying that interval and ratio. Can I say that they are examples of mean value? It means I can write over here that if somebody will be asking me, right, which data scale can be talked about if we are talking about mean, that mean, can talk about two data scales, interval and ratio. If you talk about median will be considering ratio, interval, with that ordinal also. And if you talk about mode, then if you talk about mode, then it will be considering ratio, interval, ordinal and nominal, everything, right? But just understand that we are talking about mean, right? So that is the ratio and the interval, right? Now I am starting with this, right? With that, guys, I am starting with the one more topic over here, that is the measures of central tendency, and we'll talk about variation after that. So what is the measure of central tendency? Let's talk about that, right? So very clear, guys, no problem. So we are talking about the measures of central tendency, right? So here what we can see, central tendency or average, right? It can be categorized into two things. One is the mathematical average and other one is the positional average. Sometimes they ask you median is example of positional or median is an example of mathematical one. It is an example of positional. So median and mode, guys, please remember, median and mode are the examples of positional average, and mean is an example of what? Mathematical average. First question is solved. M for mean, M for mathematical average. First question is solved. Second one, mean is having three types, guys. Mean is having three types: arithmetic type, geometric type and the harmonic type, right? Arithmetic type, geometric type and the harmonic type. Which one is more common? You will be seeing in MCQs also. Arithmetic mean. Arithmetic mean is the most common, right? So guys, here we are talking about what? In the central tendency, we will be talking about, in the measures of central tendency, we will be talking about mainly three things. What three things you are seeing over here? I can see the mean, I can see the median and I can see the mode. So I will be talking about the center of discussion will be around these topics only, that is mean, median and mode. And after that we shall be talking about the variation. But in the measure of central tendency, we will be talking about the mean, median and mode. Let's start with the mean. So in the mean, I have already told you that in the mean we are talking about arithmetic mean, geometric mean and the harmonic mean. Which one is most important? Which one is the most important? Arithmetic mean is the most important over here. Okay. Now we shall be moving on to the arithmetic mean, guys. Now in the arithmetic mean, what you are reading, in the 9th 10th class, simple mathematics we used to do, right? Calculate the mean, this kind of question used to come over there, right? They will be giving random data, random numbers, right? For example, these are the roll numbers of the students. These are roll number of your batchmates, right? Some random number came 15, 20, 9, 8, 5, 10, right? And then you need to calculate the mean over there. You might be needing to calculate the median. You might be needing to calculate the mode, right? So they might ask you to solve such simple tasks. So now let's go back to that era and now let's try to understand that what is mean, median and mode. So I'm starting with the mean, guys. What is the arithmetic mean? Let me tell you. Very, very simple. I know most of you guys are aware of that already. That mean is actually the sum of all the observations which you are seeing divided by the total number. Very, very simple. You know the sign which you are seeing over here, it is nothing but the sigma. It is nothing but the sigma over here, right? So this sign which you are seeing, right, this is called as sigma, and sigma sign is telling you that sum up, right? Sigma means telling you that sum of number of variables which are present right in front of you, right? So it is xi divided by n means total number, right? For an example, I am saying 4, 3, 8, 9, 5. Calculate the sum. You will be adding all of them because sigma, right? So 4 plus 3 plus 8 plus 9 plus 5 divided by how many variables are present over there? 5 variables, right? 1, 2, 3, 4, 5 variables are present divided by 5. Whatever answer you will get, I am not calculating it. Whatever answer you will get, that is the mean value. I hope you understood it. That is the arithmetic mean. I hope you got the idea, guys, what I am talking about. So here they are saying that it is defined as sum of all observation in the distribution divided by number of observation. Whatever amount of values are given, you just need to count them, right? Okay, guys. So what are the advantages? What could be the disadvantages? Advantages are, it is very easy. Its value is always definite, right? It's easy to calculate. It's easy to understand as well, right? There is no rocket science in understanding this. It is based on the observation so that it becomes a good representative. First of all, whenever the data is presented to us, we are talking about at the end data. That's why I told you in the first chapter I talked about the data. So whatever data is present in front of us, first of all, would like to calculate the mean over there. After that, median, and after that, mode, right? So that is the thing over here. What could be the disadvantage? Advantages, okay, good things we have talked about. What are the bad things? What are the disadvantages, right? And why do we need the median and mode then, right? There could be a disadvantages. That's why we need the median and mode, right? So disadvantages are that it is affected by the extreme values, guys. It is affected by the extreme values, and this is the main point over here, right? So it is affected by the extreme value. What do I mean by that? What do I mean by that? I mean that, guys, look, for example, I'm giving you the numbers, just random numbers I'm giving once again, guys. For an example, I told you that 8, 15, 23, 6, 19, and 8,532. So what I'm saying that, everything, 8, 5, 23, 6, 19, there is not much gap, right? Everything is logical. But over here, if I'm seeing that 8532, this is a big number. This is a big number present over here. So what do I mean by that? If I will be calculating the sum, obviously I will be summing up all these things and I will be dividing it that by 6 because 1, 2, 3, 4, 5, 6 variables are present over here. But whatever mean value I will be getting, it will be biased. It will be having the bias towards this bigger number, isn't it? It will be actually, it will be telling us the result towards that particular number. So that is not the good thing over here, right? That's why in these kind of cases where the bigger numbers are presenting over there, right? And that is kind of an extreme value. This over here, this is the extreme value. I'm just showing you the example, right? This is the extreme value over here, right? This is the extreme value over here. Okay. So in this case, I can't use the arithmetic mean. For those cases, I might be needing the geometric mean. So geometric mean, guys, I might be needing them for the extreme values. I hope you are getting my point. Geometric mean, can be calculated by the extreme values, right? For the fractional values, for the reverse values, for the reverse data, this can be calculated by the harmonic mean, but that is not needed for us. Right now, we should be needing that how to calculate mean. Simple question comes, right? Most of the time that this is the data and you just need to calculate the arithmetic mean. Very, very simple. Sometimes they are asking you this kind of question. The data is presenting in front of us and they will be asking you mean, median, mode. 3 things they will be asking you from the same question itself, and 4 options will be given. Very simple. You just need to calculate the mean, median, mode, and that's it. Question is solved. Right? Most of the time, if you are lucky enough. But still, if they are asking us about the extreme values, then yes, it will not be calculated by the arithmetic mean because there are errors. For that, it can be calculated by the geometric mean, or we shall go for the another method. We might be calculating the median now, right? We shall go for the another method, and that then we can calculate that by the method of median, right? Here is one more exercise, guys, for us, one more task. For example, they gave this kind of question is coming, right? For example, this value will be given and they will be asking you what is the mean, median, and mode. Median mode I will talk about later on, but right now I am just focusing on the mean only. So can you calculate the mean, guys, over here? Can you calculate the mean? However, the answer is in front of you. But over here, if you will see, what you will find is that first of all, just calculate how many variables are given in front of you. So it is around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 variables are given. That's why they put it over here. That is a 12 in the denominator, right? What was the formula? Sigma x divided by n, right? Sigma is divided by n over here. So that is the thing. Now sum up 15 plus 10 plus 19 plus 19. Okay, you will be just adding everything over here, right? And what answer you will be getting? That you can see over here. 182 you will be getting. That is the denominator. That is the numerator. 12 and 182, right? And that's how you will be getting the answer. That is the 15.7. I hope you got the idea over here, right? So everything is clear. Till now, I hope everything is clear, right? So we are done with the mean, guys. Now I'm moving on to the median, right? So one more thing over here, guys. If I'm talking about mean, you know, right? If we are talking about mean, you know, it is represented by x bar. It is represented by what? It is represented by the x bar. If I'm talking about sample, you know, but if I am talking about mean in case of population, then it is short by mu sign. In case of what? In case of population. In case of population, it is short by mu. Okay, but nothing new. Most commonly, you will be using this sign. That is the bar over the x. This sign is bar over the x. Okay, very simple, guys. So formula simply is, you know, what is the formula of mean? Mean formula is sigma xi. Sigma means sum up of x, that is the number of variables. I means total number, and n means the number of variables present over there, right? That is the thing over here. Okay, guys. Now we shall be moving on to the next category in the measures of central tendency, right? And that is the median. So mean is done. Now let's go to the median, right? So mean is done. Now let's go to the median. Second one over here, we will be talking about median, right? It is sometimes represented by this thing, MDM, you know, not MDH, it is MDM, right? It is a median. So median, if you talk about, guys, this is the central value among the number of variables which you can see, right? Number of variables present in front of you. But there is a condition. What is that condition? We'll talk about that. So thing over here is, guys, median is also, mean was easy. Median is also very easy. Now over here, we are saying that this is the central element. It is the, you know, median, I mean, median is the central element. It is a central element in a distribution when all elements are arranged in an order. When all elements are arranged in an order. Which order? Either it could be the increasing order, either it could be the decreasing order, right? Either it could be the increasing order, either it could be the decreasing order, right? I will give you the example. What is the condition over here? The variables, the elements which you are seeing, they should be present either in the increasing order, either in the decreasing order. If it is not present, then it's your job to order them in the increasing or the descending pattern, right? Increasing or the descending pattern, and then you will be calculating the mean. You will be finding the central value in it. You will be finding the central element in it. Now the point over here is, I told you that elements are arranged order. When all elements are present in arranged order, either it could be the increasing, either it could be the decreasing. If I am talking about arranging If I'm talking about arranging, ordering them, then median value comes, and median value comes means which data, which scale data you are thinking about, ordinal data. That's why in the median, in the mean I told you interval and ratio is coming. In the median, interval, ratio, along with that ordinal data is also coming, right? Because it is talking about the order. Either the element should be arranged in a increasing order, or it should be arranged in a decreasing order, guys, right? Okay, now there could be two conditions, right? Let me give you an example. Guys, here let's say 3, 6, 5, 9, 14, 6, 5. These variables are given, right? How many variables are there? How many elements are there? 1, 2, 3, 4, 5, 6, 7. If I will be asking you calculate the mean, can you calculate that? I hope answer is yes, right? Okay. Now I'm telling you calculate the median also. Now how to calculate the median? First of all, this is present in a kind of a zigzag manner. So first of all, I need to arrange it. I am arranging it. Either you can arrange it in decreasing order, either you can arrange it in increasing order, right? That is very simple maths, 5th, 6th class standard math, right? So here I will be just arranging them in this manner. So 3 will be coming first, then the 5 will be coming, then again 5 will be coming, then 6, then 6, 9 and 14. I hope I have arranged it successfully in the ascending order, right? You can arrange that in the descending or ascending, it's upon your will. Now I need to find the central element. That's it. How simple it is. It is a center. Median is a central element in a distribution. So now I need to find the center. Can you find the center, guys? Can you locate the center? Yes, you can locate very well. Yes, so this is the center. Can I say this is the center? Yes. So in my case, median I can represent it with MD and median becomes 6. Right? Median becomes 6. But if you will not arrange it in an order, then your median could have been 9. Right? And that was wrong. 9 will be present in the options. I am telling you. It will be given in your option and you will be thinking that yes, I am right. I did it right. But in reality, what happened? You just lose your marks, isn't it? So that is the thing over here. That is the trick over here. That median, just pick the central value. That is okay. But providing that you have arranged it in a increasing manner or the decreasing manner. And in the MCQ, they will not be providing the order. You have to arrange it on your own. Right? Usually the numbers are not very big, so that you will be needing so much of calculation in increasing and decreasing order. They are simple numbers only. That I have given the example. You need to arrange it in an ascending order. That is usually easy. Arrange it in ascending order. Find the center value. That will be the median. Right? I hope everything is clear till now. One more example I am repeating. One more example. This was example number 1. Example number 2. Okay, look, 4, 8, 14, 6, 4, 19. Okay, this is the example. My question is calculate the median. First of all, calculate the mean. Obviously, we will calculate it, sigma x divided by n. Then my question is calculate the median now, right? How will you calculate now? Obviously, you will say that I will be arranging it first of all. Okay, very nice. Arrange it, let's arrange. So, you should also arrange with me. 4 first of all. Again 4. Then, yes, 6. Then, yes, what should I write? 8. Okay, 14, 19. Very nice. Okay. Can you find me the central value? Now, you are looking a bit confused. Yeah, I can see that. So, basically, what you might be thinking that, two values I can see. Now, should I choose 6 or should I choose 8? Now, median should be 6 or median should be 8? Actually, nothing. Median should not be 6, median should not be 8, but the average of these two values. So, here, in this case, in the first example, we saw that total number was 7. So, it is an odd data. For the odd figure, you just need to arrange and you will find the center. You will find the central value and that's it. Your job is done and that is the median. Congratulations, you got your answer. But if it is even number, here the total number are 6 and that is the even number. If the distribution is in even pattern, obviously you need to arrange it in an ascending or descending order, whatever it is. But the trick or the catch over here is you will be finding the two central values. And these two values cannot be the answer at the same time. Right? It can only be the answer if both of those values are same. For example, either 6, either 8. in this case for an example, right? But they are different now, 6 or 8. But here, right? But here, what I can see over here, I can see that two values. So that's why I will be taking the average. 6 plus 8 divided by 2. 6 plus 8 divided by 2, how much? It will be 14 divided by 2. The answer will be becoming 7 now, right? So 7 will be my median value. Median value will be 7 in this particular case, right? Everything is clear till now? Yes. So median value would be the 7. Okay, so now we know that how to calculate the median value in the even category and how to calculate the median value in the odd category. Look over here, guys. Can you solve this example? Here what I can see, look at this one, 1 3 3 6 7 8 9. Okay, here already the order is ascending order, right? You can see over here. So simply you just need to find the center value and that will be your median. That will be your median, that is the MDN, that is your median, right? No problem with that, right? And this is the odd. In the odd, usually very, it's not a tricky situation. But now if the numbers are even, for example, here I can see 8 numbers. Now you are seeing 2 central values, right? And they are not same as well. You need to see first of all order. Yes, order is present, that is the increasing order only. So order problem is fine. But now you need to see the center value. Center value are 2, 4 and 5. So 4 or 5, both are not the answers. You just need to take the average over here. So 4 plus 5 divided by 2, that becomes what? 9 by 2, that is 4.5. That is the median over here right now. Okay, I hope there is no doubt. There is no doubt in your mind regarding the calculation of median, right? Okay, so I hope there is no doubt regarding that. So guys, with that I can write over here very comfortably that for the median, if it is odd numbers, for odd numbers I can say that median is the middle value. Very simple. There is no doubt regarding that. Obviously you need to arrange them in increasing or ascending or descending order and then you need to calculate. So it is the middle value. But if it is even number, then what you need to do? Yes, I can hear that median in that case will be the average of the middle values. Average of the middle values. Okay. So in both of the cases you should be comfortable enough to solve the median out of these two values. Okay. Either it could be the odd number, either it could be the even number. Okay, there is no third option, right? So that is the thing. In both the cases, you can be calculating it very comfortably. One more thing over here, guys. If you talk about the median is not sensitive to the extreme values. I told you arithmetic mean was sensitive to the extreme values. So median is not sensitive to extreme values. Extreme values are also called as outliers. In your MCQs, they might be given you outliers. What are outliers? Nothing but the extreme values. I told you 4, 5, 6, 8 and 10,000 number is given now. So that 10,000 is the outlier or the extreme value, right? I told you arithmetic mean is not a good idea. So for that case, either you need to calculate the geometric mean, either you can choose the option for median, right? Because it is not sensitive to the extreme values. Okay, because what will happen, that whatever the bigger number is there, right, you will arrange in ascending or descending order. Either it will be coming in the first place, either it will be coming on the last place. But what is the median? Median is the central value. If it is odd number also, then you have to choose the middle value, right? And if it is even number, then also you will be choosing it the middle value only. So it is not affected by the extreme values. For example, just giving you the example, however I know that you understood, but just for sake of it, 4, 9, 18, 15 and 8,991. So over here I just need to arrange it. So I will be arranging it like 4, 9, 15, 18 and 8,991. What is the mean value? What is the median value over here? I just need to pick out central value. This is the thing. If it is even number, for example, I can write over here, I shall be adding, let's say 19 over here. So I will be arranging once again 15, 18 and then I will be arranging in arranging pattern. I will be arranging it like this, then 19, I will be writing 19 and then 8,991, right? And then I will be choosing the central value. So I will be choosing these two will be my central value, these two. So I'll be choosing like 15 plus 18 divided by 2, right? It will be how much? It will be around 33 divided by 2, right? 33 divided by 2, and it will become around 16.5. That will be the case, right? So that is the thing, right, guys? So over here, with the bigger value, with the extreme value, or with the outliers, median is not getting affected. That is my motto, to show you everything over here, right? So that is the thing over here. I'm just rubbing it so that you are not confusing yourself over here anymore. So I hope I have proved that successfully, that how the outliers are not affecting the median values, right? However, if you will take the mean value of this one, then obviously the answer will be telling you towards that particular outlier or the extreme value, right? Okay guys, next point over here which I would like to make, that it can be in the data scales, it can be the ordinal, because we are talking about arranging the order. It can be interval, and it can be ratio, right? But in the mean, I told you, mean value, I told you that it was only interval and ratio. But in the median, I am telling you it is ordinal as well. Okay, and in the mode I will tell you nominal, ordinal, interval, ratio, everything will be included. Okay guys, once we have talked about that, now we shall be moving on to one more point. It is also same as 50th centile. It is same as 50th centile. Why 50th centile? Simple guys, there's no brainer over here. 50th centile mean if you are taking a distribution as a 100 percentile, 100 centile, actually percentile word comes from the centile also, centile only, that 100 centile, right? For example, this one, for example, I am taking it as 100 centile, I am taking the central value as a median, so that will become the 50th centile, right? That's why we are calling that as 50th centile. Okay, so no worries about that. So it is also called as the 50th centile. Sometimes in the MCQ they are asking us, that's why I just mentioned it over here, right? So once we are clear with the median, I hope there is no doubt, no any kind of doubt over there in your mind regarding the mean and median. Now I am moving on to the mode, and I want you to clear the doubt of the mode as well. I want you to understand it very, very crystal clear at what is the mode. Mode over here, guys, this is the most frequently occurring value given in a distribution, right? What do I mean by that? It is the most frequent occurring value observed in a distribution, right? Observed in a distribution. Okay, now what do I mean by this definition? I will be clearing that doubt, don't worry guys. This can be having three modes. Either the distribution can be having the single answer, right? That is the single mode. Either it could be having the two modes, that is called as the bimodal, and either it could be having more than two, then it will be called as the multimodal. If it is having one mode as an answer, that is the unimodal distribution. If it is having two mode as an answer, then it is the bimodal, and if it is having three mode, then it will be called as the multimodal. So what I am saying is that if the distribution is there, if the distribution is presenting with the single mode, right? Distribution can be having the two modes also, and distribution might be having the multiple modes also. I mean more than two, rather than multiple I should be writing more than two. Okay, that would be much better. More than two also, more than two modes. In these cases, obviously they will be called as the different values over here, and I am writing that if the single mode is present over there, then they will be called as a unimodal. Obviously unimodal, because single, uni means single. Two modes means bimodal, because it is having two values, right? Two values. If it is more than two, then multimodal, right? Then it is called as a multimodal distribution, right? Now if we talk about mode, guys, right, one more thing over here I would like to mention, because it is worthy over here. By the way guys, mode is also called as the MO, right? Mode. If you guys talk about the mode or MO, right, okay, there is a formula. There is a formula. This formula says that 3 times median is MDN, minus 2 times mean. If the mean and median is given in the question, then you can easily calculate the mode by the help of this particular formula. Okay, so please do remember that, right? Please do remember that mode is equal to 3 median minus 2 mean. Okay, there should be no doubt regarding this formula in your mind, right? You should remember this, right? If you talk about the mode, guys, it can be the part of all data scales. I am telling you that it could be nominal, it could be ordinal, it could be interval, it could be ratio. So it is a part of all data scale, right? So I am saying over here that, right, it can be arrived from all data scales. I mean, all data scales means, yes, I told you 4 types: nominal, ordinal, interval and ratio, right? About the mean I told you only interval and ratio. About the median I told you interval, ratio and the nominal and the ordinal. And here I am telling you nominal, ordinal, interval, ratio, everything can be concluded out of it, out of the mode over here. Now mode, if I tell you, it is the most preferred measure of center tendency for the nominal table. For the nominal, if I want to calculate for the nominal table, right, for the nominal data scale, right, if I want to calculate the measure of center tendency for the nominal data scale, right, for the nominal data scale, I can calculate the mode. Mode is the preferred value, mode or MO is the preferred measure of center tendency, because in the measure of center tendency we are talking about 3 things: mean, median, mode, right? Measure of center tendency for nominal data scale, right? For nominal data scale. If you guys remember over here, right, I told you in the beginning itself that we are having what? We are having nominal, ordinal, interval, ratio. Interval ratio I told you for the mean, right? If you will be writing median, then you will be calculating for the ordinal, for the interval and for the ratio as well, right? And for the mode, there is everything: nominal also, ordinal also, interval also and ratio as well, right? So that is the power of mode. And for the nominal one, there is only and only mode. For the nominal one, there is only and only mode, because you are seeing that mean is not touching upon that, interval and ratio only, median talking about ordinal, interval and ratio only, but for the nominal only mode is there, right? That's why I told you it is the best measure for calculating that, right? And it is least to be affected by outliers or the extreme values, right? That is also an important point over here, that it is least to be affected by. It is least to be affected by. It is least to be affected by which values? Yes, that is the outliers or extreme values. I told you arithmetic means cannot be calculated for the extreme values, because it was giving the bias in the results, errors in the results. That's why we shall be using the geometric mean or the median, and the mode is the best one for calculating for the calculation purpose as far as mode is concerned. As far as measures of center tendency is concerned, mode is the best thing. Here is one example in front of you, guys. They are asking you to solve the mode over here, to find out the mode over here. Look at the first one. First of all, the rule will be same, guys. You need to arrange it in an ascending or a descending pattern, right? But in the mode also, it doesn't matter much, because after all, what is mode? It is the most occurring, it is the most frequent value, it is the most frequently occurring value in a given distribution, right? So here you can see, what I can see over here is that there is 5, there is 6, 5, okay, so this is the thing over here. I can see 5, it is repeating much, 5 is the most frequent value. It is present over here in once, twice, thrice, and this is 4 times. So that's why my mode will be 5. So mode is 5 here, because it is most frequent item. Can you tell me the answer in this particular? So this was the first case over here in front of us. This is the second case. Can you tell us the answer in this one? However, it is given, but still, guys, right? Can you tell me it is unimodal, bimodal, or multimodal? The first one over here, guys. Question is open to all of you. Is it unimodal, bimodal, or multimodal? Here we are finding just one frequently occurring value. That is, only one mode is there. So here it is a unimodal distribution. It is a unimodal distribution, right? Look at the next question, guys. Second one. Look at this example. this kind of exercise for you. So 5, 6, 5, 6. Okay, so these are present over here. Can you tell me the mode? I'm seeing 5 is repeating repeatedly and 6 is also repeatedly. So 5 I'm seeing 1, 2, 3 and 4 times, and I am seeing that 6 as 1, 2, 3, 4 times. In the median, when we used to talk about the even numbers, we were getting the two central values and we used to get the average out of it. But here we are not taking the average of 5 and 6 because we are getting the 2 over here. Here the mode will be having 2 mode. Here we are getting the 2 answer as a mode. So here let it be 2. Let us not complicate it. So 5 and 6, it's not that we will be now taking the average of 5 and 6 and 5 plus 6 by divided by 2. It is 11 by 2 and now the answer will be 5.5. No, it's not like that here. Here the things are not working like that. Here why 5 and 6 will be, both of them will be, both of them are sharing the trophies, both of them are sharing the answer. So here 5 and 6 both will be considered as the answer. So here the mode will be becoming 5 and 6. So both are there. But here because we are getting 2 modes, so this kind of distribution will be called as the bimodal distribution. If 5, 6 and 8, they were repeating about 3 times, right, equally. The 3 digits are equally frequently repeated, then we could have been saying that this is here the mode can be 3 values, right, 5, 6 and 8, one example I am saying, right. So then in those cases I would be writing that as multimodal distribution because it is having more than 2 mode as an answer. Understood, right? So it's very easy, guys. We have talked about, till now we have talked about the mean, median and mode, and these are the very important parts of the measure center tendency. Once we have understood about the measure center tendency, now we shall be moving on to a very important term, guys, now, that is the variation. Measures of variation. So now let's move on to, come on guys, now let's move on to measures of variation. Okay, measures of variation. I am hoping that everyone is enjoying measures of variation. Now let's talk about that. So measures of variation, guys, if I talk about, we are having some measures of variation. First of all, we are having the very first one which I am taking, that is the range. Range means, range means there is a numbers given over here, right? In those particular number, there would be first number and there would be last number. You just need to pick that number. For an example, in front of you, long list is given, the roll number of students are given or the age of students are given. I need to find out what I need to do. Very, very easy, guys. I need to just find out the first number, right? I just need to find out the first number, that is called as the lowest number. And I need to find out the last one, that is called as the highest, right? So this is the lowest and this is the highest. So I just need to find out lowest and highest. No task, very, very simple task over here. Just find out lowest and highest. Subtract the lowest from the highest and you will be getting your answer, right? So highest minus lowest, you will be getting your higher answer. Highest was 16, lowest was 13. 16 minus 13 became 3. So range became 3. Very easy. Right, it is just the difference of highest and the lowest numbers in a given distribution, that is called as range. I hope there is no problem with that in understanding what is range, right? Now I'm coming to the next one, that is the standard deviation. So second one over here which we shall talk about, that is the standard deviation. Right? What is the standard? So we have talked about range. What is the standard deviation, guys? Standard deviation, we might be having 2 formulae over here. In the standard deviation, we might be having 2 formulae. One is for the population and another one is for the sample. What I can see over here, one is for the population and other one is for the sample. For the population, they are saying under root of, right? Standard deviation, they are saying under root of sum of differences between the, between the value of data distribution and the mean, right? So mu over here, this is the mean. X over here is the value of data distribution, n is the total number of observation, right? This is the formula for the population and this is the formula for the sample. Okay, so you just need to remember 2 things over here, right? Now we shall be moving on to the next category, that is what? That is your variance. So next category we shall be moving on, third one, that is the variance. Variance is nothing but it is the square of the standard deviation. It is just the square of the standard deviation, right? So over here, if you will do this square over here, right, what we will be finding? Square means you are doing the square of this thing. So under root will cancel out each other. So now what will happen? Now obviously what will happen is that they will be cancelling out each other. So you will be left out with this formula. Here also you will be doing same thing, square of this thing, and you will be finding out this formula. right? For the population, for the sample, they are giving the different results, right? Very easy, guys. It's just the doubling of the standard deviation is called as the variance. Fourth one, which you should know about, that is the coefficient of variation. Coefficient of variation. Okay. Let's talk about coefficient of variation. Here we are saying that the coefficient of variation, basically they are talking about the standard deviation divided by mean value. This is the x bar multiplied by 100. So this simple formula you need to remember about the coefficient of variation. Next method which we shall talk about in the methods of variation or the measures of variation, basically that is about the standard error, right? That is about the standard error. Standard error, basically they are saying that these are the errors in the different studies in terms of standard deviation. I will talk about these terms in standard deviation, standard error in detail, guys, in the upcoming sections, but don't worry about that. For now, just believe me that what is the standard error? These are the errors in the different studies in terms of standard deviation, right? So these are the error in different studies in terms of standard deviation, okay, in terms of standard deviation. Right? Okay, so that is about the standard error. Now, next term which we shall remember over here, that is, in the standard error only, we shall be talking about two important components: standard error for mean and standard error for proportion, right? So we shall be writing two methods over here, in the standard error only. One is the standard error, SE I am writing for the standard error, right? SE I am writing for standard error for the mean values, right? Standard error for mean, and so I am just writing that SEM. What is SEM? This is the standard error for mean, right? Standard error of mean says that, first of all, is it a quantitative data or qualitative data? Mean value I am talking about. Mean value was quantitative or qualitative? Mean value was quantitative. So mean value, first of all, it is used for quantitative data or qualitative data? It was quantitative data. It is a numerical data. Quantitative data, right? First job is clear. Second one, what is the formula over here? Formula you just need to remember, standard error mean equals standard deviation divided by under root of n number, right? And if you talk about the formula for standard error for, second one was the standard error for proportion. What is that? Standard error for proportion. Proportion, it is a qualitative data, so it is actually used generally for the calculation for the purpose of the qualitative data, okay? And here we need to remember this formula particularly: standard error for the proportion equals here we will not use the standard deviation, we will use the PQ divided by n under root, okay? So this would be the formula for the standard error for population, okay? Here I am saying that P over here is the prevalence, right? And Q is the 100 minus prevalence, right? And N would be the sample size, okay? So that is about the standard error for proportion, right? So please do remember these two formula over here, that what is the standard error? Standard error is a error in the different studies in terms of the standard deviation, right? We'll talk about that in the upcoming sessions also. Please don't worry about that. So it is having two parts: standard error for the mean and standard error for the proportion. Mean is calculated for the quantitative data, proportion is calculated for the qualitative data, right? So in this particular session we had a talk about the measures of central tendency and the measures of variation. Thank you.